Good evening, everyone.
Good evening, sir.
We'll get started. Okay. So, yeah. So today we'll start with ray optics and we'll start with some problems based on refraction of light. Okay. So are there any concepts which are not clear in this chapter? So we'll do some problem based on refraction of light, lateral shift, and real and apparent depth. Okay. So how is refractive index defined as? It is defined as the ratio of speed of light in vacuum to the speed of the light in a given medium. So mu is equal to C divided by V. So what about the same refractive index in terms of wavelength and vacuum, right? So you can also write it as wavelength in vacuum divided by the wavelength of the given medium. Okay. So what does Snell's law state? Mu2 divided by mu1 is equal to sin I divided by sin R, or mu1 into sin I is equal to mu2 into sin R, right? So these are all the values. Then when you talk about the refraction through a glass slab, then there is a concept called as lateral shift, and the value of lateral shift is given as T into sin I into 1 minus cos I divided by root of mu square minus sin square I. And the next concept is the relation between real depth and apparent depth. So apparent depth is equal to real depth divided by mu. So apparent depth is equal to real depth divided by mu. So once if the real depth is given and you're asked to calculate the apparent depth, divide the real depth with the value of mu. Then this is called as normal shift. So normal shift is given as T into 1 minus 1 divided by mu. Okay. So what do I mean by this apparent shift is when the object is kept in the denser medium and we have our eye placed in the rarer medium. So when the object is placed here, the object appears as if it is present at this point. So it has got shifted by a value of how much? If I take this to be t, it is t into 1 minus 1 by mu. So this is going to be the normal shift that has taken place. Okay. So having said this, we will try out some problems based on this concept. So there is a light of frequency 5 into 10 power 14 hertz, which is passed through a liquid. The wavelength of light measured inside the liquid is found to be 450 into 10 power minus 9. Calculate the refractive index of liquid. So how do you calculate? Refractive index is equal to speed of light in vacuum divided by the speed of the light in the given medium. Right. So what is going to be the speed of light in vacuum? It is going to be 3 into 10 power 8 meters per second divided by what is going to be the speed in the medium. It is going to be lambda into frequency. So this will be 3 into 10 power 8 divided by 5 into 10 power 14 into what is going to be the frequency? It is 450 into 10 power minus 9. Okay. So on solving this, you should get the answer as 1.33, which is going to be the refractive index of this liquid. Okay. I hope you could understand. Shall I proceed?
Yes, sir.
The refractive index of glass is 1.5 and that of water is 1.3. The speed of light in water is 2 into 10, 2.25 into 10 power 8 meters per second. What is the speed of the light in the glass? Do it fast, 1 minute time. So refractive index of water divided by the refractive index of glass is equal to speed of light in glass divided by the speed of light in water. Right? Because refractive indices are inversely proportional, which implies 4 by 3 divided by 3 by 2 is equal to Vg divided by Vw, which implies Vg is equal to 8 by 9 into Vw. Vw is going to be 2.25 into 10 power 8. So this should go 0. So 225, how many times does it get cancelled? 0.25 times. So 0.25 is 1 by 4. So 2 into 10 power 8 meters per second should be the answer. Okay. So that's what they've written 1.95 because they didn't take 4 by 3, they took it as 1.33 itself. Solve this. A ray of light passes through a plane boundary separating two media whose refractive indices are 3 by 2 and 4 by 3. The ray travels from medium 1 to medium 2 at an angle of incidence 30 degree. What is the angle of refraction? So sin I divided by sin R is equal to how much? It is mu2 divided by mu1. So sin I is going to be 30 degree divided by sin R is equal to mu2 is 4 by 3 divided by 3 by 2, which is going to be 8 by 9. So sin R is equal to sin 30 into 8 divided by 9. So it is going to be 4 by 9. R will be sin inverse of 4 by 9. Okay. Similarly, if the ray travels from medium 2 to medium 1 at the same angle of incidence, then sin I by sin R will be equal to mu1 by mu2. Okay. So sin 30 divided by sin R is equal to mu1 is 3 by 2 divided by 4 by 3, which will be 9 by 8. So sin R will be equal to half into 9 by 8, which is going to be 9 divided by 16. So R will be equal to sin inverse of 9 by 16. I hope it is clear.
Yes, sir.
Okay. Now we'll try out some problems that are based on total internal reflection. Okay. So what do you mean by total internal reflection? When a light ray is traveling from denser to rarer medium, and when the angle of incidence is greater than an angle called as the critical angle, then the ray will start bending back into the same medium, right? Or when it is incident at critical angle, the angle of refraction would be 90. So both are the same. So what is going to be the refractive index of the denser medium? So if I take the refractive index here as mu and here as 1, so mu into sin C is equal to 1 into sin 90. So sin C will be equal to 1 divided by mu, or C is equal to sin inverse of 1 by mu. Okay. So when will total internal reflection take place? When the angle of incidence is greater than the critical angle. Do this fast. Find the value of the critical angle for the material. So C is equal to sin inverse of 1 divided by root 3. Calculate the speed of the light in the medium whose critical angle is 30 degree. So sine 30 divided by sine 90 is equal to speed of light in air, that is 3 into 10 power 8 divided by the speed of the light in the medium. So speed of light in medium will be 3 into 10 power 8 divided by sine 30, which is going to be, how come?
Sir, it's 1 by nu, right? So it will be V by C.
No. How I wrote is, I wrote denser by rarer. See, what I did is, if this is going to be 30, here this is 90, okay? So here the speed of light is 3 into 10 power 8. Oh yeah, refractive indices are inversely proportional, right? Correct. So it should be Vm divided by C, correct? So Vm divided by C, half is equal to Vm divided by C is how much? 3 into 10 power 8. So answer will be 1.5 into 10 power 8 meter per second. Okay, it is exactly half. Next. Determine the direction in which a fish underwater sees the sun setting. So there is a boundary. There is a fish here. Okay. And the fish is observing the sunset. Okay. So if I take this to be the critical angle, here the refractive index is going to be 4 by 3 and the outside medium's refractive index is 1. So what will be the answer? Sine C into 4 by 3 will be equal to 1. So sine C will be equal to 3 by 4. C will be equal to sine inverse of 3 by 4. So this is the angle at which a fish underwater will be able to see the sunset. Okay. The next concept is refraction through spherical surfaces. So when the boundary is going to be spherical in nature, if the object is placed in medium of refractive index mu1 and the image is formed in mu2, for instance, then if I take this to be I, and if this distance is V, and if this distance is R, and this is U, then what will we write? Mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. Okay. So this, if you can remember and apply proper sign convention, you don't need not remember this one. You apply proper sign convention, that will give you the answer. Okay. So this formula is sufficient for us to solve the problems. So light from a point source in air falls on a convex spherical glass surface. So how is the convex spherical glass surface going to be? Whose refractive index is 1.5. The distance of a light source from the glass is 100 centimeter. If I take this to be M, right? Find the position of the image formed. V is equal to how much? C is R. So this is 1.5. Here it is 1. So mu2 divided by V minus mu1 by U is equal to mu2 minus mu1 divided by R. For unknowns, we will not apply the sign convention. Mu2 is 1.5 divided by V is V only, minus mu1 is going to be 1 divided by minus 100 is equal to mu2 minus mu1, 1.5 minus 1 divided by capital R. Capital R is how much? It is 20. So 1.5 divided by V plus 1 by 100 is equal to 1 divided by 40. So 3 by 2V is equal to 1 by 40 minus 1 by 100. So how much will be the answer? 100 minus 40 divided by 40 into 100. That is going to be 60 divided by 40 into 100. This and this will get cancelled. It will be 3 by 2. So 3 by 2 and 3 by 2 will get cancelled, which implies 1 by V is equal to 1 by 100 or V is equal to 100 centimeters. So the value of V is going to be 100 centimeter. It is formed at a distance of 100 centimeter from the refracting surface. Okay. Solve this. The diameter of a glass sphere is 15 centimeter. A beam of light strikes the sphere, which converges at a point 30 centimeter behind the pole of the spherical surface. Find the position of the image formed if mu is equal to 1.5. You have a glass sphere like this, whose diameter is 15 centimeter. Okay. A beam of light strikes the sphere, which converges at a point 30 centimeter behind the pole of a spherical surface. So where is it going to be formed? Are you guys there, first of all?
Yes, sir.
So glass sphere of diameter is 15 centimeter. A beam of light strikes a sphere which converges at a point. So observe, there is a beam of light which is striking the sphere, which is getting converged, right? And an image is formed at which point? At 30 centimeter. From where? From here. This distance is going to be 30 centimeter. And the refractive index of this glass is found to be 1.5. Right. Now, we need to find the position of the image if mu is equal to 1.5. So what the meaning of this is, had the second refracting surface not existed, then the rays which were coming would have actually fallen at 30 centimeter. That is what the question says, which converges at 30 centimeter behind the pole of the spherical surface. Find the position of the image. Now, if you know the refractive index of the glass, means what would have happened is double convergence would have taken place. I don't know where the image is formed. Let me say it is formed at I. Then what are we supposed to do?
Sir,
Tell me.
sir, behind the pole means like where will the image?
So if you take this side, you're standing, then this is where you say behind the pole. Behind the pole, na, is 30 centimeter.
Okay.
See, meaning of the question is refraction at spherical surface. In the previous problem, what I did is I took only one refracting surface. But here, how many do you have? Two. So due to the first refracting surface, first part of the sphere, the rays are getting converged so that the image is formed at 30 centimeter behind the pole. Now they will get converged again. So they'll
Yes.
get converged again so that the image is formed at some other point. Now calculate that image, the position of the image is what they're asking. So how to calculate it?
Sir, so
No,
the image will
this
be
is-
the object for the second conversion.
Perfect. That is what I was expecting. So the image formed due to the first refracting surface will act as the object for the second refracting surface. So if I take this point to be M, so with respect to the second refracting surface, tell me what are all the points. This distance is going to be 15 and it is going to be air medium. Here it is 1.5. Okay, it is 1.5. And what are the radius of curvature? It is going to be 7.5. Now tell me, if this is mu1, this is going to be mu2, then what will happen? Mu2 by V minus mu1 by U is equal to mu2 minus mu1 divided by R. Mu2 is how much? 1.5 divided by V is, that is what we need to calculate. Minus how much is mu1? Mu1
One.
is 1 divided by object distance is, it
15
is plus 15 is equal to mu2 minus mu1. 1.5 minus 1 divided by R is
minus 7.5.
minus.
solve this and tell me what is the answer. Answer. Seven 7.5, write it as 15 by 2, 1.5 minus 1, write it as half. So which implies 1.5 divided by V minus 1 by 15 is equal to 1 by 15. Sorry, minus 1 by 15. So this and this will get cancelled, which implies V is 0. So what is the meaning of this? V is 0 means it is formed at this point M. Are you able to understand what I am saying? So it is formed at this point M. So since they took this point to be the pole, with respect to the pole, where is it formed? It is formed at a distance 15 centimeters behind it. Okay, so that is the answer. In the solution, it is solved in a different way. They took everything with respect to the first. It will confuse you, but I hope this method is clear. Did you understand what happened? So it's the same logic throughout this chapter. What do we need to do? Image formed by one will act as the object for the other. Okay. The next is Lensmaker's formula. So what does Lensmaker's formula tell us? 1 by f is equal to mu2 divided by mu1 minus 1 into 1 by r1 minus 1 by r2. What does mu2 stand for? mu2 stands for the refractive index of the glass medium. And mu1 stands for the refractive index of the outside medium. Okay. So again, when it comes to the sign convention of focal length of convex and concave, focal length of convex surfaces is going to be positive and focal length of concave is going to be negative. So having this in mind, let's solve. Okay. So radius of curvature of each face of biconvex lens made of glass of refractive index 1.5 is,
Biconcave.
sorry,
Biconcaves.
where is it? What are you saying? Biconcave?
Sir, it's biconcave, right?
In this problem, huh?
Ah,
I have to see. The radius of curvature of each face of biconcave lens. It is given, no? Yeah. Each face of biconcave lens made of glass of refractive index 1.5 centimeter is 30. Calculate the focal length of the lens in air. So 1 by f is equal to mu minus 1 into 1 by, I directly wrote it as mu minus 1, you would have understood. 1 by R1 minus 1 by R2. So 1 by f is equal to mu minus 1 is half into 1 by, what is the value of R1? Minus 30 minus 1 by R2 is plus 30. Because when you draw this side you will have R1, this side you will have R2. So R1 is negative, R2 is positive. So half into minus 2 by 30, this and this will get cancelled. This is 1 by f. F will be equal to minus 30 centimeter. So focal length will be negative of 30 centimeter. I hope it is clear. Right? Next. The radius of curvature of the faces of a double convex lens are 10 centimeter and 15 centimeter respectively. Find the focal length. If focal length is 12 centimeter, what is the refractive index of the glass? So how to solve this? 1 by f is equal to mu 2 divided by mu 1 minus 1 into 1 by r1 minus 1 by r2. So 1 divided by focal length of a convex lens is positive. So 1 by 12 is equal to mu 2 is mu minus 1 into 1 by R1 is how much? 10 minus 1 by R2 is minus 15. So 1 by 12 is equal to mu minus 1 into 25 divided by 150. So mu minus 1 is equal to 150 into, 150 divided by 12 into 25, which implies mu is equal to 150 divided by 12 into 25 plus 1. This will cancel this 6 times. This will go 2 times. So 1 plus half is going to be 3 by 2. So refractive index of the glass is going to be 3 divided by 2. I hope it is clear. A uniconvex lens has focal length of 2 by 3 times the radius of curvature of either of the surface. It should have been biconvex. Okay. Or see, uniconvex here, they're trying to say that the radius of curvature for both the lenses is the same. A uniconvex lens has a focal length of 2 by 3 times the radius of curvature of either surface. Calculate the refractive index of the material. So 1 by f is equal to mu minus 1 into 1 by r minus 1 by minus r. So 1 by f is equal to mu minus 1 into 2 divided by r, which implies 1 by f is how much? 2 by 3 times radius of curvature is equal to mu minus 1 into 2 divided by r. R and r will get cancelled, which implies mu minus 1 is equal to 3 by 4, or mu is equal to 1 plus 3 by 4, which is 7 divided by 4. So 7 divided by 4 is going to be 1.75. Okay.
Yes, sir.
Next. thin lens formula and linear magnification. Okay. So when I talk about the focal length of any lens, it is given by the expression 1 by v minus 1 by u is equal to 1 by f. Then what is the magnification? Magnification is equal to v divided by u. Right? So there are certain sign conventions to be followed. In Cartesian sign convention, u is always taken to be negative. In case of convex lens, v is positive for real image and negative for virtual image, and f is positive. So in case of convex lens, v is positive for real image, negative for virtual image, and the focal length of a convex lens is positive. For concave, u, v, and f all are going to be negative. So if magnification is positive, it is going to give you a virtual image. If it is negative, it is going to give you a real image. Right? Now, a convergent beam of light passes through a diverging lens of focal length 0.2 meter and comes to the focus at a distance of 0.3 meter behind the lens. Find the position of the point at which the beam would converge in the absence of lens. 1 minute. Let us start with this. Then we'll go to that problem. Answer?
Is it 5 centimeter?
Is there a?
Height of image.
It's enlarged. So did you draw the ray diagram and see? I mean, did you draw an approximate diagram at least? So if you take the convex lens to be like this, and the focal length is taken to be 10 centimeter, such that the middle point of the needle is at a distance of 20 centimeter from the lens. So if I take the length of the needle, it is going to be 10 centimeter. So from the center, the midpoint is at how much distance? It is at a distance of 20 centimeter from the lens. Find the length of the image formed. See, since focal length is 10 centimeter, where is this object actually kept? So what will this point be? See, the midpoint is at a distance of 20, okay? Then how much will this distance be? Is this not going to be 15?
Yes, sir.
Means it is beyond the focus. So what will this point be? It will be 25. So here it is 15, here it is 25. So center of curvature will be here. Means where is the object actually kept? between C and F. So what should happen to the image? It should be enlarged. Okay,
Sir,
so
can
what?
you-
Huh?
Sir, can you repeat it?
See, look at the dimensions. Okay, 10 centimeter needle is placed in such a way that the midpoint of the needle is at a distance of 20 centimeter from the lens. Okay, so the right tip of the needle will be at a distance of 15 centimeter, because the 10 is broken into two equal 5s. This is 5, this is 5. I hope you're able to understand what I'm saying.
Yes, sir.
So 20 minus 5, 15. So 20 plus 5 on the other side is going to be 25. So focal length is 10 means what is going to be the what is going to be the position of the first point? I mean, is it not beyond the focus? Point A of the needle reclada, is it not behind focus? Beyond focus? Okay.
Yes, sir. Yes, sir.
Other than a center of curvature, B will be center of, actually it is wrong. So B is the center of curvature. So point B is beyond C. So point A is between F and C, point B is beyond C.
Yes, sir.
So find where the image for A is formed. Image for A, 1 by V minus 1 by U is equal to 1 by F. I'll write 1 by V1 minus 1 by U1 is equal to 1 by F1. So 1 by V1, I don't know, minus 1 by, what is the value of U1? Is it not minus 15? Is equal to 1 divided by F1 is going to be 10. So 1 by V1 will be equal to 1 by 10 minus 1 by 15. 15 minus 10, so 5 divided by 150, which implies V will be equal to 30 centimeter. So on the right hand side, A dash is at a distance of 30 centimeter from the lens. Am I clear with this? Similarly, image for B will be where? 1 by V2 minus 1 by U2 is equal to 1 by F2, which implies 1 by V2 minus 1 by, what is the value of U2? U2 is going to be 25 minus 25 is equal to 1 divided by F2 is going to be 1 by 10. Now 1 by V2 is how much? 1 by 10 minus 1 by 25. So how much will be the answer? 15 divided by 250. So what is the value of V2? 250 divided by 15.
Sir, focus will be minus 10, right?
No. For convex lens, focal length is always positive.
In the second case also.
Yeah. In both the cases, it's the same. So, 250 by 15 evlo. 250 by 15 is how much? 50 divided by 3. So here you will get 50 by 3. And here you will get 30. So 50 by 3 minus 30 is going to give you the answer.
Sir, I have a doubt, sir.
Tell me then.
In this type of sum, if they ask magnification, how do we find it, sir?
Here magnification. In this
Yes,
problem,
sir.
there is no concept of magnification because with When is magnification defined? It is the size of the object to the size of the image. Here you can't calculate it. Now, whatever you calculate, the size of the length of the image, right? That is what is magnification in this case. You calculate magnification. I mean, you calculated the size of the image. If magnification is needed, divide that value with the original value. So in the problem, it is going to be 13.33 divided by 10. So the image has got magnified 1.33 times. Okay.
Yes.
So the next question is based on power of lens. Okay, so what is power of lens? It is defined as a reciprocal of focal length, 1 divided by f, or it is also written as 100 divided by f if f is taken in terms of centimeter. So what is going to be the power in this case? So power will be equal to mu minus 1 into 1 by r1 minus 1 by r2. Where did we get this from? From the lens maker's formula, right? Similarly, if two lenses are in combination, if they are combined together, then m will be equal to m1 into m2 into m3 into so on till mn. Similarly, what will happen to the focal length? So focal length combination will be 1 by f1 plus 1 by f2, or it is also equal to, if you write it in terms of power, p will be equal to p1 plus p2. Okay, so this part is not there. Whether separated by distance is not a part of your syllabus. So let's not worry about it. It is not VIE, it is THE. The radius of curvature of each surface of a convex lens of refractive index 1.5 is 40 centimeter. Calculate its power. So basically what you do is you calculate 1 by f. 1 by f will be equal to mu minus 1 into 1 by r1 minus 1 by r2. So mu minus 1 into 1 by r minus of minus 1 by r. So this will be equal to mu minus 1 into 2 divided by r. This is 1 by f. So 1 by f is going to be power. So power is equal to mu minus 1, 1.5 minus 1 into 2 divided by r is going to be 40. It is going to be 20. So 0.5 divided by 20 is going to be 1 by 40. So power will be equal to 40 diopter. No. Power will be equal to 1 by 40. That is going to be 0.25 diopter. Correct, Ada? 40 centimeter other. So power is equal to 1 by 40 into 10 power minus 2. So 100 by 40. 100 by 40 is going to give us 2.5 diopter. Okay. Solve this and tell me the answer.
Sir, can you show the previous question? Yes, sir, got it.
So double convex lens of 5 diopter is made of glass of refractive index 1.5 with both the faces of equal radii of curvature. Find the value of curvature.
So I said 20
So
centimeter.
20?
Centimeter.
Correct. So 5 will be equal to mu minus 1 into 2 divided by r. So mu is 1.5. Idum cancel idum. R will be equal to 1 by 5. That is going to be 0.2 meter, or it is going to be 20 centimeter. Okay. two thin lenses of focal length 10 centimeter and minus 5 centimeter are kept in contact. What is the focal length and the power of the combination? So F1 is 10, F2 is minus 5 centimeter. When they are kept in contact, what is going to be the focal length? So 1 by F will be equal to 1 by F1 plus 1 by F2. So 1 by 10 minus 1 by 5. So how much is it going to be? 5 minus 10 divided by 50, or it is going to be minus 5 divided by 50. So F will be equal to minus 10 centimeter. What is the power of combination? So power will be equal to the reciprocal of this. Minus of 100 divided by 10, it will be minus 10 diopter. Right? Simple, no? So image formation by combination of lenses and mirror not there.
Sir,
Hmm.
sir, in that question, sir, here they have given focal length, right?
Correct. What is your doubt?
Sir, power will be equal to P1 plus P2, right?
P1 plus P2. Then 100 by 10 minus 100 by 5.
Okay.
How much are you getting? 10 minus. It's the same thing, no?
Yes, sir.
Next is we'll see some problems based on prism. Okay. So the concept of refraction through prism. So for refraction through prism, what are all the parameters that we are going to see? If I take this to be the angle of prism, when the ray is incident at an angle I, then the angle of deviation delta is given as I plus E minus A, where I is the angle of, this is E, sorry, delta is here. So delta is equal to I plus E minus A. And similarly for minimum deviation condition, what will happen? Mu will be equal to sine of A plus delta M divided by 2 divided by sine of A by 2. Clear? And deviation produced by prism of small angle is given as delta is equal to mu minus 1 into A. So these formulae you don't have. So let us solve some problems based on it. So prism based, you can expect few problems, okay? So calculate the refractive index of the material of an equilateral prism for which the angle of minimum deviation is 60. So refractive index is equal to sine of A plus delta M divided by 2 divided by sine A by 2. So sine of A plus delta M, 60 plus, for which the angle of minimum deviation is also 60, divided by 2 divided by sine 60 by 2. So sine 120 by 2 is going to be sine 60, which is root 3 by 2 divided by sine 60 by 2 is sine 30, which is half. So mu will be equal to root 3. $93. A ray of light passes through an equilateral glass prism such that the angle of incidence is equal to the angle of emergence. Okay. If the angle of emergence is
Sir,
Tell-
at minimum deviation, angle of prism will be equal to,
where minimum deviation, the angle of incidence will be equal to angle of emergence, and R1 will be equal to R2.
yes, sir.
A ray of light passes through an equilateral prism such that the angle of incidence is equal to the angle of emergence. So meaning of this is minimum deviation condition. If the angle of emergence is equal to 3 by 4 times the angle of the prism, calculate the angle of deviation. Delta is equal to I plus E minus A. But I and E are same. So 2 times E minus A. So 2 into what is the value of E? 3 by 4 times A minus A. So how much will you get? That is A by 2 is what you're going to get. But A is how much? 60 degrees. So angle of deviation will be 30 degrees. And what is going to be the refractive index of the prism? It will be sine of A plus delta M divided by 2 divided by sine A by 2. So sine of A is how much? 60 plus delta M is going to be 30 divided by 2 divided by sine A by 2, which is going to be 30. So sine of 45 divided by sine of 30. 1 by root 2 divided by half. So answer will be root 2.
Sir, in the previous question, how are you getting A is as 60 degrees? Sir? Okay.
Got it? Same is the case here. I hope you are able to follow, right? See, since time is limited, I'm doing it a little fast. If there is any doubt, please stop me. Okay. If a ray of light incident on a face of an equilateral prism shows minimum deviation of 30 degrees, calculate the speed of light through the prism. So there is a ray of light which is incident in such a way that it shows the minimum deviation of 30. So as we know that during the minimum deviation, the refracted ray will be parallel to the base. So if this is going to be 60 degrees, right, calculate the speed of the light. So first calculate the refractive index. Mu will be equal to sine of A plus delta M divided by 2 divided by sine A by 2. So mu is equal to sine of what is A plus delta M? 60 plus 30 divided by 2 divided by sine A by 2. 60 by 2. That is going to be sine 45 divided by sine 30, which will give you a root 2, right? So we know that the refractive index is equal to C divided by V, which implies V is equal to C divided by mu. So C is T into 10 power 8 divided by root 2. Right, this will give us 0.707 into 3 into 10 power 8. So the answer will be 2.12 into 10 power 8 meter per second. Okay. So next set of problems, oh, it's 657. Okay. So optical instruments alone, we'll see it in the next class, and then we'll go to wave optics. EM waves, I don't have much to solve because it's all theory based only. Okay. So we'll do these problems later. So are there any derivations that are problem in the 9th chapter? Are all the derivations clear?
Yes, sir.
Okay. So then we'll wind up. Okay. We'll wind up this.
Thank you, sir.
Thank
Sir.
you, sir.
Thank you, sir.
Sir,
Tell me that. Yeah, tell me.
sir, can you stop the recording?